Hi, I'm Sandy Chaika from Riverside Brookfield High School, just outside Chicago, Illinois, here to do the CS Principles daily practice session for our exam. Remember to click on the link in the video or in the video description box to access a PDF that has all the items we will be covering today. And we are going to focus on Big Idea 2 data. For first one, which of the following can be represented by a single binary digit? Select two answers. So when we look at this, the position of the minute hand of a clock is A, B, the remainder when dividing a whole number by 2, C, the value of a Boolean variable, D, the volume of a car radio. Well, the position of a minute hand has more than two options. Remember, binary, you can only have two options. So when we do this, even though we're going to select two answers, I have to make sure a binary digit only has two options, so I get rid of A. Dividing by a whole number by 2, the remainder is either 0 or 1, so that's okay. The value of a Boolean variable is true or false. That's okay. But the volume of a car radio is not okay because there's many levels. So the two answers are B and C. Look at daily video 1 and section topic 2.1 to look at bits more. For 2, an online store uses 6-bit binary sequences to identify each unique item for sale. The store plans to increase the number of items it sells and is considering 7-bit binary sequences. Which of the following best describes the result of using a 7-bit versus a 6-bit? 2 more items can be uniquely identified. A. B. 10 more items can be uniquely identified. C. 2 times as many items can be uniquely identified. And D. 10 times as many items can be uniquely identified. Well, if I have a 6-bit, that means I have 2 to the 0 through 2 to the 5th. The largest number I can get is 63. The smallest number is 0. If I have 7-bit, I have from 2 to the 0 to 2 to the 0, 1, 2, 3, 4, 5, 6. So the smallest number would be if all are zeros, which is 0. If all are ones, that gives me 127. So I can have from 64 to 128. So I doubled the number of items that are uniquely identified. It was not 2 more items. It was not 10 more items. It was not 10 times as many items. It was 2 more items. Every time we add a bit, we double the number of items we can identify. You can look more about binary and decimal conversions in 2.1 Daily Video 3. Moving on, a student enrolls at a school is assigned a unique ID number, which is stored as a binary number. The ID numbers increase sequentially by 1 with each newly enrolled student. If the ID number assigned to the last student who enrolled was the binary number 10010011, what binary number will be assigned to the next student who enrolls? So we have A 10010100, B 10010111, C 11010100, D 11010111. Well, if I increase by 1, that means that it's like adding 1. So that means I can't go to 2 here. So this is going to roll to a 0 and the 1 will be carried over. Well, with the carried over 1, that would make this a 2, which would make it 0 and carry 1 over. The 1 and the 0 then would become a 1. The other digits would not change. So when I'm looking at increasing this number by 1, I know the last 3 digits will be 100. So that gets rid of B. And I know the first 5 digits do not change. That gets rid of C. D, we had problems with the last 3 digits. So A is our answer. In our next question, a cable television company stores information about movie purchases made by subscribers. Each day, the information is summarized and stored in publicly available databases. We have the day and date each movie was purchased, the title of each movie purchased, the cities, and the number of times each movie was purchased. We have a sample portion of the database shown. It's sorted by date and movie title. So I have 4 columns with this information. Which of the following cannot be determined using only the information in the database? The date when a certain movie was purchased, the greatest number of times, the number of movies purchased by an individual subscriber for a particular month, the total number of cities in which a certain movie was purchased, the total number of movies purchased in a certain city during a particular month. So remember, we want to know what cannot be done. So I look at what can be. We do have day and date. We do have the title of each movie. We do have the cities and the number of times each was purchased. So when I look at my answers, the date when a movie was purchased, well, I do have dates and I do have the movies, so that can be determined. The number of movies purchased by an individual, nowhere here do I see individuals. So I don't think that's a problem. I think that is something that cannot be determined. The total number of cities in which a movie was purchased, well, I can see cities and movies, so I can get that. The total number of movies purchased in a city during a month, well, I have the date, so that means I can get the month, and I have the movies, so I can determine that. So the only one I cannot determine is the one that has individual subscribers. If you would like to see more on extracting knowledge from data, look at topic 2.3, daily video 2. Next question, when a cellular telephone user places a call, the carrier transmits the caller's voice as well as the voice of the person who is called. The encoded voices are the data of the call. In addition to transmitting the data, the carrier also stores metadata of the call, including information such as the time the call is placed and the phone numbers of both participants. For which of the following goes would it be most useful to computationally analyze the metadata instead of the data? Roman numeral 1, to determine if a caller frequently uses a specific word. 2, to determine the number of phone calls that will be placed next Monday between 10:30 and noon. And 3, to generate a list of criminal suspects when given the telephone number of a known criminal. Our answers are 1 only for A, 2 only for B, 2 and 3 for C, 1, 2, and 3 for D. Well, if I look at 1, remember, first of all, we're interested in knowing the metadata, how the metadata can be used. So if I want to find out to determine if a caller uses a specific word, well, that would come from the voice data. That's the actual data, not the metadata. So that immediately gets rid of A and D. For Roman numeral 2, the number of phone calls between next Monday between 10:30 and noon, well, metadata does include the time, so that would be okay. To generate a list of criminal suspects when given the telephone number of a known criminal, phone numbers are metadata. So both 2 and 3 would be useful to use the metadata. Next question. Computers are often used to search through large sets of data to find useful patterns in the data. Which of the following tasks is not an example where searching for patterns is needed to produce useful information? Credit card company analyzing credit purchases to identify potential fraudulent charges is A. B is a grocery store analyzing customers' past purchases to suggest new products the customer may be interested in. C, a high school analyzing student grades to identify the students with the top 10 highest grade point averages. And D, an online retailer analyzing customers' viewing habits to suggest other products based on the purchasing history of other customers. When I'm looking at this, I want to know which one uses patterns. And so a credit card company analyzing credit purchases to identify potential fraudulent charges. We're looking at large data sets, and we want to know which one's not using patterns. Well, I actually believe the credit card does use patterns to determine which ones are fraudulent. The grocery store analyzing past purchases to suggest new purchases. Well, they're looking at the patterns of what the customer bought, so that does use patterns. A high school analyzing grades to get the top 10 highest GPAs. That's using calculation and maybe comparison, but that does not appear to use a pattern. An online retailer analyzing viewing habits to suggest other products for the purchasing history of other customers. That's looking at patterns of what people have watched. So that is using patterns. C is the only one that did not use a pattern. Question 7, we have a table that shows the time a computer system takes to complete specified tasks on the customer data of different size companies. The tasks are backing up data, deleting entries, and searching through data, and sorting data. The company sizes are small at 100 customers, medium at 1,000, large at 10,000, and how much time each of those takes. Based on the info in the table, which of the following tasks is likely to take the longest amount of time when scaled up for a very large company of approximately 100,000 customers? Backing up data, deleting entries from data, searching through data, or sorting data. Well, the backing up data goes from 2 to 20 hours, which is a multiple of 10, and 20 to 200, which is a multiple of 10. But that seems reasonable since the amount of customers is also a multiple of 10. Deleting It goes from 100 to 200 and 200 to 300 based on the size of the company. So it's going up linearly, always just increasing 100. So when it goes up linearly, that's probably not going to take as much time. Searching through data goes from 250 for small to 300 to medium to 350 for large. Again, it went up on a linear level of just 50 hours, even though I went up 10 times that in customers. So that's not going to take that much more. But sorting data, even though we only go up 10 times for the amount of customers, the amount of time, 0.01 hours to 1 hour, is going up 100 times. From 1 hour to 100 hour, it goes up 100 times. So I multiply for every amount that I go up by 10 times for a customer, I go up 100 times for the time. So that is our answer, sorting data D. Question 8, a student is recording a song on her computer. When the recording is finished, she saves a copy on her computer. The student notices the saved copy is of lower sound quality than the original recording. Which of the following could be a possible explanation for a difference in sound quality? The song was saved using fewer bits per second than the original song. The song was saved using more bits per second than the original song. The song was saved using a lossless compression technique. Some information is lost every time a file is saved from one location on a computer to another location. So remember, we're looking at the saved copy was lower than the original. So could the song being saved use fewer bits per second than the original? It's possible. If it used more bits per second, then I would expect it to actually be better. So that's not the answer. The song was saved using a lossless compression. Lossless means it would be the same as the original. That's not the answer. The information is lost every time a file is saved from one location and the computer to another. That should not be happening just from one location to another in the same computer. But the fewer bits per second is our answer. That's an example of lossy compression. If you want to look at more at compression techniques, look at 2.2 Daily Video 1. Now we're going to look at two lists. List 1 and 2 contain names of books found in two different collections. A librarian wants to create new lists, which will contain the names of books found in either list in alphabetical order with duplicate entries removed. List 1 has Macbeth, Frankenstein, Jane Eyre. List 2, Frankenstein, Dracula, Macbeth, and Hamlet. The new list should be Dracula, Frankenstein, Hamlet, Jane Eyre, and Macbeth. We have some procedures that can be used. Sort list, we'll sort the list in alphabetical order and return the resulting list. Combine list 1, list 2, makes a new list with everything from list 2 after list 1. And remove duplicates, we'll go through and remove any duplicates from the parameter list that was sent. So which of the following will make this happen? I'm going to skip A for now. You might know why, but let's go ahead and look at B. List 1, sort list, we'll sort all the elements in list 1. List 2, sort list 2, we'll put them in alphabetical order. But now when I combine list 1 and 2, everything from 2 will be after list 1, which means we will be losing the alphabetical order. And we want alphabetical order with duplicates removed. And notice that we have some duplicates within each list, but we also are going to have them in different order when we combine them after it. So I will lose alphabetical order. C, if I remove duplicates from 1 and remove duplicates from 2, that's fine. But when I combine list 1 and 2, Macbeth was in 1 and in 2. So they're going to be there. That's going to combine, and Macbeth will stay there in both. So I'm going to have a duplicate. In D, I'll remove duplicates from 1 and sort it. Remove duplicates from 2 and sort it. Then I'll combine. The duplicates, again, could end up being there, and I will be out of alphabetical order. So A seems to be the answer. That's because I combine. List 2 will come after list 1. Then I'll sort, so I'll get my alphabetical order of all of them, and then I'll remove duplicates in the new list. If you want to look more at examples of using a program to process data, look at 2.4 Daily Video 1. Thank you for coming, and I wish you luck on your AP exam.